tonight?
So, I know like last time we were doing a bit of unit circle. So what in a unit circle, I just don't understand like how to apply it.
Okay. Trying to think of how to explain it. I'm not quite sure what you're not understanding about it. So problems usually are the best way to go about straightening this out.
Okay, so let's see. The first one, this one says find the exact value for cosine of theta and tangent of theta for theta equals 2, and then this first one is 2 pi over 3.
All right. Usually unit circle problems come down to being able to figure out a trig function of an angle that's inside the unit circle. So if you can figure out all of these kind of problems by hand, I mean manually without going to your calculator, then that's what you need to be able to do. Okay, so let's take the unit circle and figure out, this is pi over 2. This is pi. This is 3 pi over 2. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And all students take calculus, and since we're dealing in radians, let's use radians. This is pi minus theta, this is theta minus pi, and this is 2 pi minus theta. Okay, so very first thing we need to answer is what quadrant we're in.
Wait, really fast. So to get the theta minus pi for each quadrant, how did, like, is that just like a rule?
Uh-huh. It's just something you got to memorize. To me, it's the best way to do this, is to memorize these formulas. In other words, this only applies in the second quadrant. So we're in the second quadrant. 2 pi over 3 is second quadrant. So plug that in for theta. And what this gives you is the equivalent first quadrant angle. So what would that be for this one?
So you
Plug 2 pi over 3 in for theta.
Wait, and how do you know that this is the second quadrant?
Because it's between pi over 2 and pi.
Okay.
In other words, if it was 4 pi over 3, that's third quadrant. So once you spot the quadrant, then you use the appropriate formula. So what's this the equivalent of?
Pi minus 2 pi over 3.
Which is? Would be pi over 3. In other words, it's a whole pi minus 2/3 of a pi, leaving 1/3 of a pi. Now, you with me? In other words, pi minus 2/3 pi is the same as 3/3 pi minus 2/3 pi, which is 1/3 pi. Okay, so it's going to have a numerical value that is the same as that. Well, what's the numerical value of sine of pi over 3? In other words, you do have to memorize your first quadrant angles. You need to know basically how to figure out your trig function of any first quadrant angle that's 30, 45, or 60. Because our process is going to be to convert everything to that first quadrant angle. So if we know the first quadrant, then we can answer second, third, and fourth quadrant. Well, pi over 3 is 60 degrees. So go back to your 30, 60, 90 triangle, which has dimensions of 1, root 3, 2. So the sine of 60 degrees is root 3 over 2. That's its numerical value. Now the very last step is to attach a plus or minus sign to that. Well, in the second quadrant, is sine positive or negative?
Positive.
There's your answer. To the sine of 2 pi over 3 is equal to that. And that's the way we do every one of them. Is first of all, we figure out which quadrant it's in. Then we convert it to a first quadrant angle to come up with its numerical value. And then we attach the sign based on all students take calculus. So we can do that for every single one. Give me another one.
Okay. So then how does she like cosine?
Well, the key to all of them is knowing your first quadrant angles.
Oh, so you would just instead in the reference triangle take cosine instead of
Uh-huh. In other words, if the problem was cosine of 60 degrees, then that's 1/2. Excuse me one second, Sarah. Let me turn my TV down. It just came on automatically. I forget, DirecTV comes on after an hour and a half. Okay, so let's do another one. I think you'll catch on.
like cosine of 8 pi over 3?
Okay. This is outside the unit circle. Notice that it's greater than 2 pi. So first step is to get it inside the unit circle. How do I do that? Subtract or add multiples of 2 pi. In other words, you can always subtract 2 pi or add 2 pi. In other words, 30 degrees is the same as 390 degrees, which is the same as 750 degrees. So all I'm doing is adding 360. It's called coterminal angles. So in order to get this inside of one of these quadrants, I'm going to subtract 2 pi. What's 8 pi over 3 minus 2 pi? Correct. And that's exactly what it's going to be. In other words, the cosine of 8 pi over 3 is going to be exactly the same as the cosine of 2 pi over 3. So now, let's make this our problem. What quadrant?
Quadrant 2.
The equivalent first quadrant angle. Same as before. In other words, it's second quadrant, so use that.
Oh, right, that's pi over 3.
Okay, I'm going to write it in parentheses now. I've decided this is a better way to handle it. So, what's the cosine of 60 degrees? Using your reference triangles.
1/2.
And what is its plus or minus sign? Plus or minus?
So it's negative.
And it's just as straightforward as that. No matter what the trig function, no matter what the angle. As long as it is a multiple of 30, 45, or 60, we can use this technique. Got more?
Yeah, this one.
Let's do a different angle. In fact, if you have something that's third or fourth quadrant, let's do that, just so you make sure you can, it's a different formula. It's this formula or this formula. I can make one up if you don't have one.
Yeah, I think that's faster.
Tangent of 4 pi over 3. Which quadrant? What is the equivalent first quadrant angle? So use this. Pi over what?
Pi over 3.
Uh-huh. What is the tangent of pi over 3?
No, wait. Oh, so now you have to do... Is it still 60 degrees?
Uh-huh. In other words, you still have to know this. So what's the tangent of 60 degrees?
Square root of 3.
And last step, what is its plus or minus sign?
It would be... Oh, no, it'd be positive.
Correct. So there's your answer. So it's always the same 3 steps. It's identify the quadrant. That's step 1. Figure out what its equivalent first quadrant angle is. That's step 2. Step 3 is to figure out what its numerical value is, and step 4 is to put a sign on it. Same 4 steps, no matter what the angle, the trig function, or anything else is.
And well, the numerical value, that's always going to be in one of the reference triangles, correct?
As long as it's a multiple of 30, 45, or 60, it will be. Now, there's also the quadrangles, which is 90, 180, or 270. You can't get those from these 2 triangles, at least not easily. So you have to have a different way of memorizing those. Okay? The preferable way, as far as I'm concerned, is memorizing their graphs, because you kind of have to know how to do this anyway. In other words, this should be part of your memorization process already. And if you've got the graph memorized, then you can answer the quadrangles. What's the sign of 0? Read my graph. In other words, based on my graph, what's the sign of 0? What's the sign of 90 degrees? Because it's pi over 2. Pi over 2 is the same as 90 degrees. Pi is the same as 180 degrees. 3 pi over 2 is the same as 270.
So it's 1.
Correct? What's the sign of pi, or 180 degrees?
2.
Notice that no answer is outside of the range -1 to 1. There is no such thing as the sine of an angle equals 2. In other words, it's got to be between -1 and 1. No, the sign of pi is 0 again. The sign of 180 is 0. What's the sign of 270? And what's the sign of 2 pi? Okay, so that will answer all of your quadrangles for sine. This will answer all of them for cosine. And notice the similarity here. These both divide into quarter points. And the quarter points are key points. Those are your quadrangles in every case. And cosine is very similar to sine in that it bounces back and forth between +1 and -1. So what's the cosine of pi? Okay, so if you have these two curves memorized, now you can do almost all trig functions for any angle that's a multiple of 30, 45, 60, or 90. The only thing we can't yet do is tangent. Well, it's worth memorizing the tangent curve also. Now the tangent's a little different in that, first of all, its period is pi. It goes from minus pi over 2, minus 90 degrees, to plus pi over 2. And it goes from negative infinity through 0 up to positive infinity with these vertical asymptotes. Completely different than sine and cosine. And then it repeats every pi. Okay, so based on this, and the key point here would be pi over 4, and that's where tangent is equal to 1. So what's the tangent of 0? What's the tangent of pi over 2, 90 degrees? Undefined. Or infinity. Positive infinity. In other words, as you approach pi over 2, this thing goes to infinity. So those are the key points for tangent. You don't generally ask about the tangent of pi, although the tangent of pi is 0, because it's right there. The two more important curves are sine and cosine. The sine and cosine, you really need to memorize those. Tangent, yes, maybe no. It's certainly useful to memorize it, and it allows us to finally answer the question, any trig function for any angle that's a multiple of 30, 45, 60, or 90. But you need that tangent to get the tangent. Now, to get the secant and cosecant and cotangent, those are just reciprocal of these. In other words, I know that cosecant is the reciprocal to sine, and therefore cosecant sits on the tops and the bottoms of the sine curves, like that. And the reason I know that is because it's the reciprocal, because sine is equal to 1 over cosecant. Well, when sine is equal to 1, cosecant is going to be equal to 1. So they both need to share that point right there, and they both need to share this point right there. So that's the reason I know that it sits on the tops and the bottoms.
Wait, so what would be like the cosecant of pi then?
Well, cosecant of pi would be undefined because you're dividing by 0. In other words, because cosecant of x is equal to 1 over sine of x, when you plug in pi for x, you got 1 over 0. And therefore, the cosecant curves have also vertical asymptotes in them. The cosecant, here, let's draw extended, that's sine. Here's the cosecant. And the cosecant have vertical asymptotes wherever the sine is equal to 0. And then let's erase the sine curve, because it doesn't belong. It's just I use it kind of as a reference point. There's the cosecant curve. One full cycle of the cosecant curve. And it goes out to 2 pi. This is pi. So notice that cosecant of pi would be undefined. It's the same thing as tangent of pi over 2, because it's division by 0, essentially. And then the secant sits on the tops and the bottoms of the cosine curve. If we go back to the cosine curve, if I wanted to draw the secant, sits on the top of that hump and the bottom of that valley. And the only curve we haven't talked about is cotangent. Cotangent also has vertical asymptotes every pi, and it essentially looks very similar to the negative tangent curve. In other words, this is the tangent over here. This is the cotangent. One is almost the negative of the other, except it's in a different place on the x-axis. Notice the tangent curve straddles the y-axis. The cotangent curve does not. Cotangent curve borders the y-axis.
So
Okay. I'm going to go ahead and erase these just because I needed room to write. Negative angles. We haven't done any negative angles. Do you have any of those?
I don't have...
Well, I'll give you one. What is the sine of minus 30 degrees? Now, you may not have had much in the way of negative angles yet, but you'll be getting it in the IB program for sure. So it's not going to hurt to talk about them if you want.
Is it quadrant 4?
It is, but there's something else about negative angles that's worth knowing. And that is the sine of a negative angle is the same as negative sine of the positive angle. Whereas the cosine of a negative angle, because cosine is an even function, that's equal to the regular cosine of that same angle. So you have two ways of doing negative angles. Using the property of the odd and even function is the best way to do them. But there is another way to do them, and that is to convert them to positive angles. Let's just do one real quick and I'll show you the difference. If I wanted to do, in fact this is the way I used to do them. If I wanted to do the sine of 30, well that's that angle right there. Well, that's the same as that angle. So that should be identical with the sine of 330 degrees, right? All coterminal angles are the same. So by taking this angle and adding 360 to it, I don't change anything. It's going to give me exactly the same value as the sine of minus 30. Okay, well I know how to do the sine of 330. What quadrant is that in?
Quadrant 4.
What's its equivalent first?
30 degrees.
Yep. What's the sine of 30 degrees? And what is the plus or minus sign in the fourth quadrant for sine?
It would be negative.
Okay. So that took 1 step, 2 steps, 3 steps.
Yeah.
Okay? Let's do it the faster way, which is to see that we know sine is odd function. So the sine of minus 30 is the same as minus sine of 30. Well, I know what sine of 30 is. That's positive 1/2. Bingo. I'm done.
Wait. Oh, okay.
Okay, let's do cosine of negative 30 in the same manner. Cosine of negative 30 is the same as the cosine of 30. What's the cosine of 30?
Square root of 3/2.
It's in the fourth quadrant, it's positive, excuse me, it's in the first quadrant, it's positive. There's your answer. So that's what you can do with negative angles. And the only one we didn't talk about is tangent. Tangent is also odd. So the tangent of minus theta is minus the tangent of theta. And that's the best way to do tangent. fact, it's the best way to do all your negative angles is to apply the property of whether it's odd or even.
Okay.
Instead of converting it to a positive angle. You can do it that way also. It'll give you the same answer, it's just there's 2 extra steps. All right. We've got about a half hour. If you want to go longer, I can.
Can we just like go to about 5?
Yeah, we can go to any time, and I'll just register the amount of time and charge you for just that amount. In other words, I don't round up to the nearest half hour or anything.
Okay, so yeah, to about just like 10 more minutes would be fine.
Perfect. What other problems do you have?
If we can, let's see, this one. If cosine of theta equals 3/4, find the possible values of sine of theta.
Okay. This is a classic trig question where they give you one trig value and then they ask you about the other 5. And given one trig value, as long as you know which quadrant it's in, you can figure out the other 5. How do we do it? What's the very first step that I want to do once they give me this function right here? Draw a triangle, a right triangle. And label theta, very important. Now, let's dimension this triangle. What 2 sides can I label based on the given information?
You can label the hypotenuse and then like the opposite side of the hypotenuse.
It's not the opposite. Well, it's the adjacent side to theta. That's 3. Okay? When you're talking trig, when you talk adjacent, you mean the adjacent side that is not the hypotenuse. Because obviously theta has 2 adjacent sides. Right? They're always talking about the one that is not the hypotenuse. So it's always this one here, if you're talking adjacent to theta. Okay? Now, we have 2 sides of a right triangle. We can always figure out what the third side is. What's this side over here? You want to get so you can solve right triangles quickly. Okay? And the way to do it is to not go all the way back to this. When you have to go all the way back to the Pythagorean theorem, it just takes too long to solve them. So always know that when you're solving a right triangle where you've been given 2 sides, the third side is always the square root of something. In other words, your answer should always start out square root of. Well, when you're solving for one of the legs, it's the square root of the hypotenuse squared minus the other side squared. If you're solving for the hypotenuse, it's the square root of the other 2 sides, a squared plus b squared. So that's the only 2 situations you have, is where you're either solving for one of the legs or you're solving for the hypotenuse. So it's good to memorize this, what I have circled here. It makes it so much faster to solve a right triangle, and that's something you're going to have to do 100 times in the next 2 years, is solve right triangles. angles. It's just a very, very common thing they want you to do. So this is the square root of 16 minus 9, so it's the square root of 7. Now, sometimes it might be the square root of a perfect square. In other words, if I were to give you this triangle, well, this is the square root of 3 squared plus 4 squared, which is the square root of 25, which is equal to a whole number, 5. But the answer still starts out square root of. And that's a really good thing to remember, that if you're coming up with answers that aren't square root of, you're doing a mistake. Okay? Back to our problem, which 3 goes there, 4 goes there, square root of 7 goes there. Now you can answer all trig functions. What did they want? The sine of theta?
Find the possible values of sine of theta.
Okay, what is it?
Square root of 7 over 4.
Uh-huh. Now, the only thing that makes this problem different than your prototypical problem is that they didn't specify which quadrant we were in. They just said the cosine of theta was 3/4. Well, that could be fourth quadrant. In other words, they could have said cosine of theta is 3/4 and theta is greater than or equal to 3 pi over 2 and less than 2 pi. That's the typical problem, is where they give you a trig function and tell you which quadrant it's in. You still do this. You still draw a right triangle. It's the best way to solve it. Okay? Once I've dimensioned my right triangle, now I know that the sine of theta has to be root 7 over 4. But if it's in fourth quadrant, it's negative. So there would be my sine of theta. Okay?
Okay.
Okay?
You don't know, it can either be square root of 7 over 4 or negative 4?
Yeah, the way they've worded the problem, when they say give all possible values for sine of theta, and that kind of leaves it open. They don't tell you what quadrant it's in. So if it can be any quadrant, it can either be plus or minus square root of 7 over 4. Because it could be either first quadrant or fourth quadrant.
Yeah.
But that's not the typical question. The typical question they would tell you what quadrant it's in. Now, the thing you don't want to do here, and this is what a lot of people might attempt to do, is if the problem starts out like this, where they say cosine of theta is 3/4 and we're in the third quadrant, do not do this. Complicates the problem way more than necessary. Just always start this problem out by drawing a right triangle, labeling theta. Obviously that's not in the third quadrant, but we're going to do it based on the first quadrant values. I can still do this. And I can still figure out that the sine of theta has a numerical value of that. Now all I have to do is put the right plus or minus sign on it. Well, I know sine of theta is negative in the fourth quadrant. Personally, I think this is the best way to solve these problems. In class, they might draw the unit circle. They probably would. I'm guessing that if you got this problem in class, they would try to solve it by doing this. And then they would end up making a reference triangle and dimensioning the reference triangle. And going from there. But to me, that adds an unnecessary step of complicatedness to it by going to the unit circle and finding the exact quadrant. It's so easy to do it if you just always make that your first step. Do you have one more of those? Let's have you do it real quick. We got just a couple minutes.
This one says, it's like a little different. It says, suppose the cosine of theta is square root of 11 over the square root of 17. And theta
What's the rest of it?
is an acute angle.
Okay, so theta is in first quadrant. That's all that means. Okay.
And then it wants you to find the exact value of tangent.
Okay. How do I proceed?
So would you make a triangle first?
Not just make a triangle, but make a triangle and label theta. Because if you don't label theta, you can't dimension this triangle. In other words, if I don't put that in there, I have nowhere to begin. So you have to put in theta. Okay, now dimension the triangle for me.
So then the adjacent side is the square root of 11. And then hypotenuse is square root of 17.
So what's this side?
Wait, you add them?
No, remember your answer starts out square root of, and you're solving for one of the legs. So when you're solving for one of the short sides, there's going to be subtraction going on inside the square root of.
So it's square root of 6?
Uh-huh. In other words, it's the square root of the square root of 17 squared minus the square root of 11 squared, which is the square root of 6.
Yeah.
Now you can give them any trig function they want. You could do any of the 6 trig functions now that you have this triangle fully dimensioned.
It would be negative, square root of 6 over the square root of 11.
Yeah, but there's a problem with that. What do we have to do to that? Got an irrational number in the denominator.
Oh, just, okay, so then you would have to square root of 11.
What would you do?
You would multiply by the square root of 11.
You'd multiply top and bottom by square root of 11. In other words, I can multiply any fraction by the number 1 without changing its value. So I can't arbitrarily multiply something by square root of 11. That would change its value. But I can certainly multiply it top and bottom by square root of 11. Well, that gives you what? Square root of 66 over 11. And that's your answer.
Okay.
I think 66, is that divisible by 4? No. It's not divisible by 9 or 16 or 25. So that's simplified. Okay. You good to go, Sarah?
Yep, I think so.
All righty. I will talk to you next time. I'm glad you called. Always do that if something doesn't, if you're expecting a session and you don't get it, call me.
Okay.
Okay? All right. Bye-bye.
Thanks.